What's happening, everybody? All right, we're in a brand new chapter now, chapter 14, and this is gonna be our last chapter involving calculus. And what we're going to be focusing on in this chapter, last calculus chapter, is we're going to be focusing on calculus involving trigonometry. So, pretty cool. Brush off your unit circles like I told you in class. You're going to need those again. You're going to need to understand how to graph periodic functions, those types of things. All right. What we're going to be doing in this section is we're going to be starting off by finding derivatives of trig functions. And in particular, our first goal is going to be to use rules for differentiation in order to find derivatives of trigonometric functions. All right, now rules for trigonometric functions, or rules for derivatives, rules for differentiating that I'm talking about, that's going to be things like the product rule, the quotient rule, the chain rule. All these things that we learned back in chapter 7 are going to come into play right now, except that we're going to be using them along with trigonometric functions. All right, so let's get an example. Well, before we get an example, we need to learn some rules, actually. Let's learn some rules for finding derivatives of trigonometric functions. And I'd like to find the rules for three things in particular. We're going to write down the rules for finding the derivative of sine x, for cosine x, and for tangent x. And these are just new patterns that you need to memorize. And they're pretty simple. All right, first of all, if f of x is equal to the sine of x, that would imply that f prime of x would be equal to the cosine of x. All right, the derivative of sine x is always going to be equal to cosine x. All right, and the derivative of cosine x is almost what you would think it is based on that first rule. The derivative of cosine x ends up being the opposite of sine x, or negative sine x. All right, and the last differentiation rule that we're learning here is that for the tangent of x, and it turns out that the derivative for the tangent of x is equal to 1 over the square of the cosine of x, or 1 over cosine squared x. Now, there's no reason for us to go into why these derivatives are what they are, certainly not the latter two. We can talk about, and you can look in the book actually to find out why the derivative of sine x equals cosine x. But what I'd like in this video is to show you how you differentiate using these three rules. All right, so now we're ready for some examples. Let's go ahead and do this. We're going to find the derivative of 4 cosine x minus 2 sine x. Now, as we come upon these trigonometric functions that we're differentiating, I'm going to point out the rules that you already know that we're going to be using. For instance, we haven't talked about how to find the derivative of 4 cosine x, but we just talked about how to find the derivative of cosine x. And if you ever have a constant times a function, then the derivative of that is just the same constant times the derivative of the function. So, f prime of x. We're still going to differentiate term by term just like we would with polynomials, by the way. The derivative of 4 cosine x would be 4 times negative sine x. Right? And then we can put minus 2, and then we can just multiply negative 2 times the derivative of sine x, which is cosine x, right? So, that's going to give us negative 4 sine x minus 2 cosine x. All right, now that's the simplest of the examples, but you can see how we're using the same rules that you already know in order to do these differentiations. All right, next problem. We're going to differentiate y equals tangent of 3x squared. All right, now I just rewrote that same function using colors here because I want to point out that in this example, we've got an outer function and an inner function. And yes, I hope you're picking up what I'm putting down here. We're trying to use the chain rule because we've got a derivative of a composition that we're working with. The outer function, being what's in red here, is just the tangent of x, and then the inner function being 3x squared. And remember, the way that you find the derivative of a composition is by finding the derivative of the outer function first. And the derivative of the outer function with respect to the inner function is 1 over cosine squared of 3x squared. All right, when you differentiate the outer function, keep the inner function inside of it. And then you multiply the derivative of the outer function by the derivative of the inner function. And the the inner function's derivative ends up being 6x. All right, now another thing we're going to work on with these trigonometric derivatives is writing the expressions in simplest form. And I would like to write this all as a single fraction, and that'll simply be done by putting the 6x up in the numerator. All right, so here's what the final answer would look like. All right, and the most challenging thing that you're going to be doing in this section is using the chain rule. And in a couple of examples, the last two, you're going to end up having to use the chain rule twice within the same problem. All right, but it's not beyond you by any means. Next example. All right, now first thing we're going to do with this one is we're going to rewrite it so that you don't have this cosine of x in the denominator. And we're going to do this just the way that you guys are used to doing it with other types of functions. We're going to say that y is equal to 2 times the cosine of x to the negative first power. All right, and here's where we're going to have a composition once again. Let me try to show you what that composition is by rewriting this expression in colors again. All right, you see the outer function is basically x to the negative first power, a nice power function, and the inner function is the cosine function that you see right there. So, first thing to do is to use the power rule in order to find the derivative of the outer function. All right, you can see that I multiplied the coefficient that was already there by the original exponent, so we got a negative 2, and then I decreased the exponent by 1. All right, and I left the inner function inside of there. Now, I need to differentiate the inner function. And we have already established that the derivative of the cosine of x is negative sine x. All right, the last thing to do is to clean this up. You see how a cosine of x has a negative exponent? So we're going to put that in the denominator. And then the negative 2 and the negative sine x, we're going to multiply those and put the result in the numerator, so that this is what the final derivative looks like. Negative 2 times negative sine x gives you 2 sine x. And then if you move cosine of x to the negative second power to the denominator, it becomes the cosine of x squared. And remember, when you're squaring or cubing or whatever exponent you're using along with the trig function, you can put that right after the name of the trig function and before the angle measure that you're plugging into the trig function. All right, 2 more examples to go through. And each of these are going to be the ones I was referring to where we have to use the chain rule twice. All right, and so I want to show you how we can rewrite this function. And there are actually 3 functions that are involved here. All right, look at this. All right, for the outer function, we have the sine cubed of 4x. I'm just pretending that's the sine of 4x, and then I'm moving the exponent outside. We've got a power, a third power function. Then, inside of that, we're going to write this. All right, we're still going to have the sine of 4x in the inner thing, but notice that the sine of 4x is a sine function composed of a linear function. So, we've got the outer function, which is a cubic function. We've got an inner function, which is a sine function. And we've got an inner function, if you will, which is a linear function. All right, now let's start by differentiating the outermost function. Okay, so you can see I brought the 3 in the front, decreased the exponent by 1, left the same thing on the inside. And now we've got to differentiate the inner function, but it's kind of the middle layer, if you will, the sine of 4x. So let's do that. And if you differentiate that, the sine of 4x, you're going to get a cosine of 4x, but then we still have to differentiate the innermost function, right? And the derivative of 4x is simply 4. Then the last step of that is let's go ahead and just clean this up. Alright, there's no negative exponents, so we don't have to worry about fractions here. We simply just have to go ahead and multiply everything together. So I've got a 3 times a 4. I'll go ahead and put a 12 up front. Then let's go ahead and write the sine of 4x squared as the sine squared of 4x. And then we'll attach the cosine of 4x at the end. Alright, there's one more because I want you to try one, and it is also, as I've said a couple times at this point, going to involve the chain rule twice. Take a look at that, copy it down. This is a pretty tough one. I'll be impressed if you can get it. Try it. Alright, first thing was for me to rewrite this so that I didn't have this tangent in the denominator. And you can see I went ahead and wrote it where I've got the outer function is the power function, x to the negative 2 basically. And then the middle layer of the functions is you've got a tangent function. And then the innermost function is this x cubed. Alright, I'll continue to show you the work here as you're checking yours. And there you see the derivative of the outermost function. Alright, and then the derivative of tangent x, if you remember, was 1 over cosine squared of x. So we made this 1 over cosine squared of x cubed. And then finally, the derivative of the innermost function. And the derivative of the innermost function is 3x squared. Alright, now for the cleanup work. We've got fractions involved here. You already see the one fraction from where we differentiated the tangent. And we've got a factor that has a tangent being raised to a negative exponent, so that's going to be brought to the denominator. In the numerator, we're going to have a negative 8 times a 1 times a 3x squared, so that you end up with negative 24x squared over the tangent cubed of x cubed times the cosine squared of x cubed. Alright, so there's how you differentiate using trigonometric functions, and you still need to learn how you apply those things. You still need to learn how to integrate with trig functions. Those are all things we'll do over the rest of the course of this chapter. Thanks for watching. Good luck.